American armor had proven effective in World War II and Korea. Tank units had supported infantry operations, broken defensive positions, and provided mobile firepower across varied terrain. By the early 1960s, the United States Army maintained sophisticated armored forces trained for conventional warfare. The M48 Patton medium tank represented the latest generation of post-war armored development. When American military advisors began arriving in South Vietnam in larger numbers, the question of armored support emerged naturally. Commanders familiar with armor's capabilities in previous conflicts saw potential applications in Southeast Asia. The initial assessment suggested that armored vehicles could provide valuable support to South Vietnamese forces. Roads existed throughout the country, particularly in the populated lowlands and along the coast. Rice paddies, while soft, appeared similar to terrain in Korea where tanks had operated. The Viet Cong, unlike the North, Korean or Chinese armies lacked significant anti-tank capabilities. Early planning documents reflected confidence that armor could enhance mobility, provide fire support, and offer protection to personnel moving through contested areas. These assessments were based on reasonable interpretation of available information and experience from previous conflicts. The first American armored units arrived in Vietnam during 1965 as part of the broader commitment of ground forces. The 1st Squadron, 4th Cavalry deployed with M48A3 Patton tanks and M113 armored personnel carriers. The 1st Battalion, 69th Armor followed shortly after. These units brought extensive training and experience with their equipment. Crews had practiced maintenance procedures, gunnery, and combined arms coordination at bases in the United States and Germany. The tanks themselves had undergone modifications based on Korean War experience, including improved suspension and upgraded engines. Everything suggested readiness for deployment. The M48A3 Patton weighed approximately 48 tons. Its design reflected decades of armored warfare development. The 90mm main gun could engage targets at ranges exceeding 2,000 meters. Armor protection provided security against most infantry weapons and artillery fragments. The vehicle carried a 4-man crew with defined roles developed through years of doctrinal refinement. Maximum speed on roads reached 30 miles per hour. Fuel capacity allowed for extended operations between refueling. On paper, the specifications indicated a capable combat vehicle suitable for a wide range of missions. Early deployments focused on areas where terrain appeared favorable. Units established bases near major population centers and road networks. Initial operations involved familiarization with local conditions and coordination with South Vietnamese forces. Tank platoons conducted patrols along main roads, provided security for bases, and responded to reports of enemy activity. These early missions proceeded without major difficulties. Roads, while rougher than American highways, supported tank movement. The vehicles attracted attention from local populations unfamiliar with such large military equipment. Crews began adjusting to tropical heat and humidity, which differed significantly from temperate climates where they had trained. The first challenges emerged during routine operations rather than combat. Tank commanders discovered that visibility from their vehicles differed dramatically from training areas in the United States. In open terrain at Fort Knox or the plains of Germany, commanders could observe hundreds of meters in all directions. In Vietnam, even in relatively open areas, vegetation along roads and in fields limited observation. Rice paddies, which appeared flat and open from a distance, featured dikes, tree lines, and structures that created numerous blind spots. Commanders found themselves operating with less information about their surroundings than they had anticipated. Movement off established roads presented immediate difficulties. The first attempts to maneuver across rice paddies revealed problems that maps and aerial photographs had not indicated. The ground, which appeared solid, often consisted of saturated soil beneath a thin crust. Tank weight caused vehicles to break through and sink into mud. In some cases, tanks became immobilized after moving only a few meters from hardened roads. Recovery required winches, additional vehicles, and substantial time. These incidents occurred during routine movements, not under enemy pressure, allowing crews to extract vehicles without interference. The experiences raised questions about off-road mobility that had not been prominent during planning. Maintenance requirements increased beyond anticipated levels. The tropical environment affected mechanical systems in ways that temperate climate testing had not revealed. Air filters designed to handle dust clogged more rapidly than expected when exposed to the fine, humid particulate matter common in Vietnam. Seals and gaskets deteriorated faster in high heat and humidity. Electrical systems experienced corrosion that maintenance schedules developed for other climates did not adequately address. Crews found themselves performing more frequent maintenance while operating in conditions that made the work more difficult. Working on a tank in 100-degree heat with high humidity exhausted personnel quickly. The initial expectation that armor could operate throughout South Vietnam required revision. Maps indicated extensive road networks, but ground reconnaissance revealed that many secondary roads could not support 50-ton vehicles. Bridges designed for local traffic required weight assessments before tanks could cross. Some structures simply could not bear the load, necessitating detours or engineer support to construct bypasses. What appeared on maps as connected road networks often consisted of disconnected segments separated by obstacles that tanks could not easily overcome. This geographic reality limited where armored units could deploy effectively. Fuel consumption emerged as a more significant constraint than anticipated. The M48 consumed approximately 2 gallons of fuel per mile under moderate conditions. In difficult terrain or during extended idling, consumption increased. Vietnam's road conditions, with frequent stops, starts, and low-speed movement, created higher fuel usage than operations on European-style highways. Resupply convoys needed to run more frequently than planned. This increased logistics requirements and created additional security demands. Fuel trucks became targets, and protecting them absorbed resources that might otherwise support combat operations. Crew comfort affected operational capability in unexpected ways. Designers had considered heat in the M48's development, but the sustained tropical conditions in Vietnam exceeded parameters used in testing. Interior temperatures regularly exceeded 115 degrees when vehicles operated in direct sunlight. Crews could not maintain full effectiveness for extended periods under these conditions. Heat exhaustion became a regular concern. Commanders learned to schedule operations to avoid the hottest parts of the day when possible, but combat requirements did not always permit such considerations. Crews operating in these conditions showed reduced alertness and slower response times, factors that affected overall unit capability. Communication systems functioned adequately on established bases and along major roads, but performance degraded in other environments. Radio transmissions that achieved reliable ranges of several kilometers in open terrain reached much shorter distances when vegetation or terrain features intervened. Maintaining contact with higher headquarters or supporting units required careful positioning and frequent relay. In some areas, units found themselves temporarily out of contact during routine movements. This isolation, even when brief, created uncertainty and complicated coordination. Armor doctrine assumed reliable communications, and the limitations encountered in Vietnam required tactical adjustments. Enemy contact during the first months of deployment did not match expectations formed by earlier conflicts. The Viet Cong generally avoided direct engagement with armored units when possible. Instead of the set-piece battles that had characterized Korea, contact consisted of brief ambushes, long-range harassing fire, and mine strikes. These engagements did not allow tanks to employ their primary advantages in firepower and protection against comparable threats. The enemy adapted tactics to avoid armor's strengths while exploiting limitations that became apparent through observation. This pattern of contact frustrated crews trained for direct engagement against mechanized opponents. Mine warfare proved more significant than initial assessments suggested. Early intelligence indicated limited Viet Cong mine-laying capability. Experience revealed otherwise. Mines constructed from unexploded ordnance and other materials appeared along roads with increasing frequency. These devices, often command-detonated, could damage or destroy tanks. The psychological effect exceeded the physical casualties. Crews understood that any stretch of road might conceal a mine. This awareness created constant stress during movement. Mine detection and clearance became routine preludes to operations, slowing movement and consuming time that planners had not allocated. Visibility limitations affected tactical employment in ways that became clear only through experience. Tank gunnery training emphasized engagement at ranges where armor and firepower provided decisive advantages. In Vietnam, particularly in areas with vegetation, engagement ranges often measured in tens of meters rather than hundreds. At these distances, the tank's main gun offered limited advantage over other weapons. The time required to identify, aim, and engage targets in close terrain often exceeded the duration of contact. Enemy forces could fire and withdraw before tanks could respond effectively. This tactical reality reduced armor's effectiveness as a primary combat system. The monsoon season introduced challenges that had been understood theoretically but not fully appreciated in planning. Heavy rainfall transformed roads into mud channels. Ground that barely supported tanks during dry season became impassable. Rivers rose and flooded, cutting routes and isolating units. Visibility dropped to near zero during heavy rain. Operations that planners expected to continue year-round required suspension during the worst weather. Armor units found themselves confined to bases for days or weeks, unable to conduct missions. This seasonal limitation affected operational planning and force availability in ways that had not been prominent in initial deployment concepts. Adaptation began incrementally as units gained experience. Tank platoons started operating more closely with infantry, who provided local security and improved situational awareness. Engineers joined armored columns more regularly to address mobility obstacles before they became critical problems. Maintenance procedures evolved to address tropical conditions, with crews learning which systems required more frequent attention. Supply chains adjusted to deliver parts that wore out faster than anticipated. These adaptations represented learning through experience rather than planned modifications. The changes accumulated over months, improving effectiveness, but also revealing how much the original concept required adjustment. The M113 armored personnel carrier demonstrated characteristics that made it more suitable for some missions than the M48 tank. Weighing approximately 12 tons, the M113 exerted lower ground pressure and negotiated soft terrain more successfully. Its open-top configuration, while offering less protection, provided better visibility in close terrain. Crews could observe their surroundings more effectively. The vehicle's lighter weight made recovery operations simpler when immobilization occurred. Units began employing M113s more extensively for missions where their characteristics proved advantageous. This shift in employment patterns reflected growing understanding of which vehicles suited which conditions. Route security missions consumed increasing portions of armored unit time. Supply convoys required protection against ambush throughout the road network. Tanks provided deterrence and heavy firepower if contact occurred. However, these missions involved extended periods of movement at slow speeds along predictable routes. The defensive nature of convoy escort did not utilize armor's offensive capabilities. Crews spent hours conducting these operations, which offered limited opportunity for initiative or maneuver. The missions were necessary but did not align with the offensive spirit of armored doctrine developed for conventional warfare. Firebase defense became another primary mission for tank platoons. Fire support bases established throughout the country required protection against ground attack. Tanks positioned on defensive perimeters provided direct fire capability. Their presence offered psychological reassurance to infantry defenders. However, static defensive positions negated mobility, which represented armor's primary advantage over other weapon systems. Tanks functioned as fortifications rather than maneuver elements. This employment made sense given tactical requirements, but it represented a use case for which the vehicles had not been primarily designed. Maintenance challenges intensified as operations continued. Parts that should have lasted thousands of miles wore out in hundreds. Track life decreased, substantially on abrasive laterite roads. Suspension components failed more frequently than maintenance schedules predicted. Engine overhauls came due earlier than anticipated. The parts supply system, designed for conventional operating environments, struggled to keep pace with demand. Units maintained deadline rates higher than peacetime standards as vehicles awaited parts or major repairs. This readiness challenge affected operational capability and required creative solutions, including cannibalization of some vehicles to keep others running. Recovery operations revealed the extent of terrain limitations. When tanks became immobilized in rice paddies or off-road areas, extraction required substantial resources. The M88 recovery vehicle could retrieve tanks on solid ground, but soft or obstructed terrain complicated the process. Multiple recovery vehicles, engineer support, and sometimes construction of temporary roads became necessary. Recovery operations could take days, during which disabled vehicles required security. The resource investment to recover a single tank sometimes exceeded the combat value the vehicle had provided during the operation that disabled it. Crew rotation policies affected unit cohesion and knowledge retention. Individual replacement meant experienced crew members departed and new personnel arrived continuously. This constant personnel change prevented accumulation of expertise at crew and platoon levels. Lessons learned through experience left with departing personnel rather than remaining in units as institutional knowledge. New arrivals required time to adjust to Vietnamese conditions, during which effectiveness decreased. This pattern repeated throughout the war, creating a persistent challenge to maintaining operational proficiency based on accumulated experience. Doctrine developed for conventional warfare required substantial modification. Armored tactics assumed maneuver space, extended sight lines, and opposition that would engage directly. Vietnam offered none of these conditions consistently. Tank commanders learned to operate in single file along roads rather than in tactical formations. They learned to rely on infantry for local security rather than vehicle systems for threat detection. They learned that aggressive offensive action often meant simply moving to the next position safely. These tactical adaptations preserved effectiveness, but represented significant departures from trained procedures. The realization that armor faced fundamental limitations in Vietnam developed gradually rather than suddenly. No single event or engagement demonstrated the mismatch between vehicle capabilities and environmental requirements. Instead, accumulated experience from hundreds of operations revealed patterns. Tanks could operate effectively in some areas under certain conditions. In other environments, their contribution decreased substantially. Understanding where and how to employ armor effectively required experience that could only be gained through actual operations. This learning process took months and came at the cost of reduced effectiveness during the adjustment period. Command decisions about armor employment reflected growing understanding of limitations. Initial deployment concepts emphasized armor's offensive potential and mobile firepower. Later employment focused on missions where terrain permitted effective operations. Route security, firebase defense, and support for infantry in favorable terrain became primary missions. These roles provided value, but represented a narrower application than originally envisioned. The shift in mission emphasis occurred without explicit acknowledgement of changing doctrine, emerging instead from practical decisions by commanders at various levels. Supply requirements created cascading logistics challenges. Fuel consumption required constant resupply operations. Ammunition, while used less intensively than fuel, still demanded regular delivery. Parts for maintenance arrived through supply chains stretching to the United States for specialized components. Water for crew consumption became a significant concern during extended operations in heat. Food supplies needed protection from tropical deterioration. Each of these requirements generated its own logistics burden, collectively creating a support tail that absorbed substantial resources. The ratio of support to combat capability exceeded levels common in other operational environments. Training new crew members in country presented challenges distinct from stateside instruction. Formal training programs could teach operation and maintenance procedures, but understanding Vietnamese operating conditions required direct experience. New arrivals needed time to adjust to heat, learn terrain limitations, and develop tactical skills specific to the environment. This learning period exposed inexperienced personnel to danger while they acquired necessary knowledge. Units developed informal training programs to accelerate the process, but no substitute existed for actual operational experience. The constant influx of new personnel meant units always included members still learning fundamental aspects of operations in Vietnam. Comparison with other American vehicles revealed relative suitability for Vietnamese conditions. The M113 armored personnel carrier proved more versatile for many missions due to lower weight and better visibility. Lighter vehicles could access areas where tanks could not operate. However, the M113 offered less protection and firepower. This trade-off between capability and suitability characterized much of the equipment employed in Vietnam. Vehicles optimized for one set of conditions showed limitations when employed elsewhere. No single vehicle proved ideal for all missions, requiring mixed fleets and careful matching of equipment to tasks. The question of whether armor should have been deployed to Vietnam emerged from accumulated experience rather than initial assessment. Early confidence reflected reasonable expectations based on previous conflicts and available information. The difficulties encountered could not have been fully predicted without actual operations in Vietnamese conditions. Once present, armor provided capabilities that no other systems could deliver. The main gun's firepower, armor protection, and psychological impact all contributed to operations. However, These contributions came with substantial costs in logistics, maintenance, and constrained employment options. Lessons from early armor operations influenced later deployments and tactics. Units arriving after initial experiences benefited from accumulated knowledge about what worked and what did not. Tactics evolved to emphasize combined arms coordination, with armor, infantry, and engineers operating as integrated teams. Equipment modifications addressed specific problems identified through use. Maintenance procedures adapted to tropical conditions. These improvements enhanced effectiveness, but could not overcome fundamental mismatches between vehicle design and environmental conditions. The learning process continued throughout American involvement, with each period adding to collective understanding. The broader strategic context affected how armor employment was assessed. American strategy in Vietnam emphasized mobility and firepower to compensate for limited troop numbers relative to the area of operations. Armor contributed to this approach by providing mobile firepower and protected transport. However, the strategy itself faced challenges that armor could not address. Enemy forces avoided direct confrontation when disadvantaged and chose engagement times and places that suited their capabilities. This operational pattern limited opportunities for armor to influence outcomes decisively. The strategic environment shaped what armor could accomplish regardless of tactical effectiveness. The experience of armored units during early Vietnam deployment reflected broader themes of adaptation and limitation. American forces entered the conflict with equipment and doctrine developed for different circumstances. Experience revealed what worked, what required modification, and what proved fundamentally unsuitable. Armor fell into the middle category, providing value in specific roles while showing clear limitations in others. The adjustment process consumed time, resources, and sometimes casualties. Knowledge gained informed later operations and influenced post-Vietnam equipment development and doctrine. By 1967, armored operations in Vietnam had established patterns that would continue throughout American involvement. Units understood terrain limitations and employed vehicles accordingly. Maintenance procedures had adapted to tropical conditions as much as equipment allowed. Tactics emphasized combined arms operations that mitigated armor's vulnerabilities. Employment focused on missions where tanks could operate effectively rather than attempting operations that terrain precluded. This settled pattern represented accumulated learning from 2 years of experience. The soldiers who crewed these vehicles demonstrated adaptability and professionalism under challenging conditions. They maintained complex equipment in difficult environments. They executed missions that often did not align with their training. They adapted tactics based on experience while continuing to face dangers that their vehicles could not fully protect against. Their effectiveness reflected not just technical skill, but also ability to adjust to circumstances that differed from expectations. This human dimension of adaptation proved as important as any technical or tactical factor. The American armored experience in Vietnam illustrated fundamental military challenges. Weapons and equipment optimized for specific conditions show limitations when employed elsewhere. Doctrine developed for one type of conflict requires substantial modification for different circumstances. Learning occurs through experience, often at the cost of reduced effectiveness during the adjustment period. These lessons extended beyond armored warfare to encompass broader questions about force design, deployment decisions, and operational adaptation. The specifics involved tanks and jungle terrain, but the patterns applied more widely. Reflection on early armor deployment to Vietnam reveals tensions between capability and suitability. The M48 Patton represented sophisticated military technology backed by extensive development and testing. Its capabilities in conventional warfare scenarios remained undisputed. In Vietnam's environment, many of those capabilities found limited application. The vehicle could not be blamed for failing to excel in conditions it was never designed to address. Similarly, commanders who deployed armor based on reasonable assessments drawn from previous experience made defensible decisions with available information. The mismatch between equipment and environment emerged through experience rather than oversight. The gradual recognition that armor faced fundamental constraints in Vietnam shaped how the war was conducted, but did not resolve underlying strategic challenges. Armor provided valuable support where terrain permitted. It could not overcome geographical and tactical realities that limited its employment. This pattern characterized much of the American experience in Vietnam, where technological sophistication and military professionalism confronted circumstances that diminished their effectiveness. The specific story of armored vehicles illustrated broader themes about the relationship between military capability and operational environment. Understanding how early armored deployments unfolded provides perspective on military adaptation. The process was neither dramatic failure nor complete success. Instead, it represented steady adjustment as experience revealed what worked and what did not. Units learned to employ armor effectively within environmental constraints. They developed tactics that maximized contributions while acknowledging limitations. This pragmatic adaptation enabled armored units to support the broader mission even as it became clear that their vehicles were not built for Vietnam's jungles, paddies, and roads. The learning process itself became an important part of the story, demonstrating how military organizations adapt to unexpected circumstances through accumulated experience and practical innovation. Thanks for watching. See you next time.